Ooh, it says you're live. Hopefully that's actually the case. All right, cool. Everyone, please fill out the attendance link if you can. I'll leave it up there for an extra second. Why does snow exist in this world? I don't know. It sucks. Questions at Offset Club exist. That doesn't seem to be an issue for this group because I've already gotten 2 questions. So that's a good time. Someone asked in here, how did CPTC go? Will we get a rundown? Probably next week. Not entirely sure yet. It's been kind of a mess of a weekend. Oh my gosh, there's questions. We'll try and bring it up next week and maybe talk a bit more, although I'm not entirely sure yet. Oh geez. Now I need to clear these. How do I submit a question? Okay, now that I've gone through my notifications, we've got a mock competition. Not sure if that's the right date because I totally didn't write this slide during a class. So everyone here should hopefully be participating in this mock competition. There's a group of DSU people that are going to be red teaming, and you can sign up for a blue team at the link that's there. It's a really good time. If you want to do offensive things in the future, you should also be doing defensive because you can learn a lot about the other thing by going in between the two. It's kind of a weird field in that regard, but it's a good idea to do both. Like last year, I didn't do blue team for mocks, I was red team, but I was still able to go and blue team for a competition with Chris where we ended up getting 4th in the nation. So it's a good idea if you want to do offensive to do defensive. I believe there will be full-on injects where you get interrupted from whatever you're doing, and they're like, hey, fill out this presentation to give to our CEO about why this security product is worse than the other or something. And your goal is going to be to kick red team out offensive. So everyone here, I can't type. Sign up link should be in the OffSec channel a little bit up, or that link there. What we've got for upcoming clubs, tomorrow I'm going to be presenting again in this room probably. I don't think we're going to switch to East Hall 100 or 105. And it's going to be talking about the recent ACM competition that we did. Some of the problems from there. Some methodologies probably. I'll be trying to explain other people's code because Logan tells me to write janky code. So I'll try and run through his logic and what I ended up typing since I was the faster typer, and it'll be a good time to see me up here struggling a lot. Computer Club on Monday, we're going to talk about results of Sanford Tech Summit. I'm not sure if teams are going to be giving their presentation again or how that's going to work. So if there's faculty members that want to see it, like Sean back there, he can finally see it. DevSec, I don't know what they're doing. This is a guess, but it's probably going to be an overview of the mock that will have happened on Saturday. So it'll probably talk about here's what red teamers did, what did you guys find, how did you secure stuff, and just kind of a good get together on stuff that you should have found or weird things you found that no one even anticipated. OffSec next week, we don't entirely know yet. We might have Mark Spanier here to talk about some crypto stuff. We might have an RE lab. So just be watching your email if you're interested. And hopefully we'll have a result by whenever that email goes out on Saturday or Sunday. Okay, current events.
That was the most efficient way to walk around that.
Yeah, it was, especially because you were coming that way.
Yeah.
Bandwidth. So I did a very good job this week of current events. I was in a meeting that went longer than I thought it was going to, and I was like, well, I'll have time to add a couple more. So we don't have very many. So the first one, this one's actually pretty neat. Someone actually posted this in Slack, but I thought I should throw it up here. So there's a nice pseudo CV, and I believe it affects versions before 1.8.9. Just off the top of my head, I think that's it. You can look it up and be like, no, you're wrong. But basically, Users that have permissions to sudo as other users or with other user IDs, something along those lines, you can use these nice numbers, so like a -1 or the, oh god, I don't want to count threes.
Max
So basically int max
+1.
+1. So what it does is it puts you at that -1, but then -1 becomes 0 because of how evaluation worked, and 0 is the ID that you need for being root. So then you're able to sudo using that. So it was actually a really neat thing that people missed, and just kind of integer overflows and like stupidity stuff like that still happens, which is kind of neat to know, and gives people who are new to like bug bounties kind of some hope. So there's that one. I was really frustrated about this one. So this is Adobe Reader has been like, oh, somebody put the sudo. So it's sudo version 1.8.28. Is that the one it was patched in, or is that the patched? Okay, so it's probably stuff before that then. Yeah, so this one was pretty interesting. They've actually had a time lately. There's a whole lot of CVEs for Adobe Reader DC. Them just not fully like taking care of like stopping JavaScript from doing things. But basically you could run, and I say basically a lot, you could run arbitrary JavaScript and you could heap corrupt. If you were careful with how you did things, supposedly you can get remote code execution, but there's no proof of concept that I could find. And once again, I didn't spend a whole lot of time looking for it. I looked through like a bunch of websites that typically have proof of concept code, but I couldn't find anything for this one. So if you find one, that would actually be a really good share in OffSec if somebody finds that, like in the Slack channel. And then, oh, nice. So Apple fixed the squid emoji. So this little doohickey. Oh, I was gonna do Kyle's enhance thing, but you rebinded it to something else.
And then scroll.
Enhance. They moved this to the back of the squid's head, so anatomically correct. And that's that. So that was current events this week. Sorry about that. But now we're gonna actually talk about really stinking cool stuff. So one of the cool things with like being in offensive security or like doing security stuff is the opportunity to kind of develop your own tools and things along those lines. So we actually have a couple examples of doing just that. Does anybody know what C2 stands for? Yeah, I see head nods, but basically like command and control stuff. So you've got a master and then a subservient machine that you're controlling. Yeah, something that listens. So that's a better term to use. I was being careful. So yeah, so we'll have some information about that. I don't know who wants to go first. Do you want to go first? Yeah?
Oh, is that your last slide?
Yeah.
Okay.
Squeeds. And then this was Zach's stuff, so. Yeah,
All right.
we're ready for you, so.
You can take my computer down.
Okay.
And then we're gonna pray to the OBS gods that
hopefully they just correct.
this is gonna work.
Okay. Scared for a second. All right. Well, okay, so today we're going to be talking about how to create your own backdoor and your command and control, so you can listen to your backdoor connections and maybe send and receive some data using Python, of course. Anyone here use socketing before programming? Like, oh, we have a lot of people here. That's good. So this should be interesting. So here's our outline. This is what we're going to use. Network sockets, Python exceptions. So you Python programmers, they Do you know that? Command execution using subprocess module. This is the main ingredient here. We know how to write multi-threaded server, control our clients, like close the connection and interact with our clients or our backdoor in this scenario. Write your own receivable function. We will get to that in a minute. And we need also to know how to inject a meterpreter, download, upload files, and finally create an exe using Pyinstaller so you can send it to someone. So what we need for this is to connect. How do you connect to your, well, it's going to be the opposite. It's going to be your backdoor will be connecting to you, and you need to know how to send and receive data from your backdoor, and to terminate or close connection in case you're done with your backdoor, you want to close your connection. So first, how to create a socket using UDP. This is the syntax in Python. I'm not sure exactly how you write this in C programming, but I'm pretty sure it's much harder. Yep. Yeah. You have to define so many things. Same thing for TCP, but Python made everything easy for us. And so here, the only difference between the UDP and this TCP is the dgram here, the sock_dgram. The TCP is the stream one, and the IPv4 is the inet, and just add 6 to it, it will be IPv6. It's very easy. Then we get to the server. So here, the first thing we do is after we create our socket, we bind to like IPM port. You can use your local IP address, like this one here, or you can just leave it empty.
You got a question? Over like the computer to your left, you can see it up there. Someone just put something in there for you. So I think that was something on the last slide.
Oh, this
If
one?
whoever put that question
Explain
wants to ask a
what that
clarifying
does.
thing.
I'm not sure
So it just says, can you explain what that does?
what's that? I don't know, like. Oh, this like creating the socket maybe? That one?
Like, what did I don't know who asked it, but what did each of those do?
It came in while he was well into the
Well, I'm not sure. So let's. So usually our backdoor, it works as a client. It will connect to our server in this case, and the send and receive. So we're sending data and receiving data from our backdoor. The close one, we can use that to close our socket when we're done with it. We're not using it anymore. And here, we are just defining our socket, what kind of protocol we're using, what kind of IP we're using, like V6 or V4. And then we get to that. To actually write this, we have first to import our socket module, first line, import socket. And then we define our UDP socket. And then we bind to interface. That means we are telling our server that we are listening for incoming connection on our 127.0.0.1, or like I said, if you just remove that, it'll be empty string. That means you're listening on all the interfaces. And then we print the only difference between UDP, if you want to receive or send data, is to receive, it's receive from. To send, it's send to, here in this slide. But in TCP, it's just send and receive. So, yeah, that's just UDP. Get to the TCP in a second, yep. So the TCP is the same, but we just changed the sock_stream instead of the dgram. And we, of course, sock_stream is the TCP, and we gotta make sure it's unique source and destination IPM port. Again, we connect if we want to do outbound connection, and we bind to the IPM port. Same thing with the UDP.
There's another question. Why TCP versus UDP? So, like, why are you using UDP for your example instead of TCP?
No, in my scenario, like if you're creating a backdoor, we are using TCP. But UDP, some people using it not for backdoors, but just for fast connections because it doesn't have, the header is not that big, like doesn't have a lot of information like the TCP, and you don't have to worry about the sequence retransmission and overhead of the UDP. So some people do that if they're using like video streaming. Yeah, but we don't need to do that now because we don't care about the fast connection. We just need everything to be accurate. Okay, so yep, so the same thing, we bind to the IPM port. You can just leave it as empty string, and then you will listen on all the interfaces. Here we tell our socket, the one we just created in a variable, TCP socket here, but we just say socket as a variable. They'll listen, and then the number of connection we want to listen to. It can be 5, 10, whatever you want. And then we accept the connection. So when we accept the connection, you get a connection from your backdoor, and you will get more information about it. You get the information like IP and port of your backdoor or your socket object. We will get to that in a second. But in case if you want to know like how it works in the background, like in like three-way handshake, there's no way we can like know that, because in Python they hide this kind of information from us. You can't tell where's the acknowledgement number or sequence or anything. But if you want to do this, you have to do the raw socketing in Python. Maybe we'll do that another time. So now if you want to send and receive data, again, it's kind of like UDP, but it's a little bit different. Just send and receive instead of send to and receive from. But here is very important. The length of the data you're receiving, if it's 0, that means the connection is dropped. So you can use that to tell at the backdoor something happened at the other side. So sometimes the exe file or the backdoor, maybe he will just close it. If that's the case, you're not getting any bytes, then it will be 0. And here the accept, the socket.accept, it will give you information about the IPM port and the socket object itself that we will use later to send and receive data, and that's the most important part. Here's an example using netcat to send content of a file to a grapper.py. It's very simple code. You just connect to the netcat, and the netcat is using the file to send .text as input, and it will send that to the Python once it connects to it. And then we will do a while loop to keep printing, but in this case it will just keep printing, and it will be stuck on the receive because we don't have if statement to tell it to break or do something if you're not receiving anything. But just a simple example. Try and accept. I don't know why they call it accept. It should be expect or something like that, but yeah, sure. So we're trying to concatenate a string and integer, and we get that error. Type error cannot concatenate string and int. So we don't want any errors in our code. We just do some kind of error handling. So that's the case. We're using try and accept. Here we are using accept, and then the actual type error. I mean, it's kind of type error, but it's the type of the error. Here it's type error, and then we told it to do something else if you get this error. And this is actually what happened. It printed on the screen, you cannot concatenate string and integer. And then here we can add another exception, accept exception as E. You don't have to put as E, just for short. Oops. Here we are telling our code if anything else happened, do this. Some other exception happened, and we are printing our error. In this case is the E. Now we get to the subprocess. So the subprocess is if you want to execute commands on the target, we need to use a subprocess module. first we import it, uses the import sub process, and then we create a variable to use a popen to hold information like the command you're executing, the shell. Of course, you need to leave the shell equal to true, otherwise nothing will happen. And of course, we are defining the standard output and error here. The second line is the exit code. It's a variable just to tell us if the code was successful or not. And here, the result, we are just getting the standard out. You can put them in the same line, standard out.read plus standard error.read. So in this case, it will send you everything, the standard output and the error also. Yeah, here we don't have any errors. I mean, it's fine. Here, the proc.wait, this is what we talked about. It will give you 0 if the command was executed successfully. You can use that to check if your backdoor is doing a fine job. We get to the multi-threaded server, because if you're not using multi-threaded servers, then you cannot have more than one backdoor and control them at the same time. You need connections from multiple clients or backdoors. So here it's the same thing. We are just creating our socket. The second line here is just to reuse the same IP and port. Because if you're not using this, sometimes if you close your application or the server and you try to bind on the same port again, you get an error that it was still in the memory or is being used by another application. So the second line, we use that to keep using the same port again. And then we bind on 127.0.0.1, listen for 5 connections, and then we go into the while loop. And here the C and address, ADDR, are just 2 variables to hold our information. The C will have the socket object itself, the one that we will use to send and receive data. ADDR this one will hold our IP and port, the IP and port that connected to us. We will get to that in a second. And then we start a new thread using the start_new_thread module. We have to import that from threading. This is the function that we have to import from the threading module. And once you call the start new thread, you have to give it 2 parameters. The first one is the actual function that you want to use to send and receive data. And the second input or the second parameter will be the actual socket object itself that you will send and receive data from. We will see that in details. So here the C, address. So the address, we are using that to hold our IP and port. It's a list. So address, the first element is actual our IP address, and the second element, address 1, is our port number. And we can, when we accept our connection, so the socket object will be saved in the C variable. So we need to save those backdoors or clients somewhere so we can get to them later. So you can append them to a list, like list of clients that append, and then C in parentheses. So you will have a list of all the socket objects that you have. And then also you can use a number to mark them, like this is connection number 1, connection number 2, 3, and so on. You can use like a number, like thread_number, and increment that every time you get a new connection. Save that in a list also. So here, so this is a threaded function. It's just a function called threaded, and it takes 1 argument. The C, the socket object that we just received. This is just a simple test. We are printing like open thread from a new client. Data, here data equals C.received, so we're waiting our backdoor to send us some data. Once we get that, we can print it to the screen. So how do you manage your sessions? So in a command and control, like the meterpreter thing, you have this console that you can just write some commands, but at the same time, everything happening in the background. So you can define a new function that has like a raw input to it, that takes commands from you, and you can start your new function using a start new thread. You can start that as another thread. It'll be in the foreground and everything else will be in the background, using the same concept. But if you're not passing any parameters to your function, it should be empty like this one. Okay. So comma, but the other one was just comma. And here, get back in a second. Yeah, C, comma, and that's it. But this one, since we're not passing any argument to our function, we just leave the parentheses empty. So this is our goal, to add each socket object to a list, give each session a number, and increment it, add each connected IP to a list. Once we do that, we can interact with a specific target. We can loop, like parallel loop through all the lists that we have, the list of clients, session numbers, and IPs, using the zip function to like parallel loop through all of them. And then here we are trying to get a specific IP for like the third variable. If IP is equal to this IP, we'll send this command, assuming the command is just a variable that you have already. And then you wait for reply from your backdoor, and then you just print it on the screen. So how can we get a big buffer from our backdoor? That's a bit of a problem. Anyone know about this problem in Python? So here, the client side on the left, we're sending 10 times 1024 times 400, and that's the total bytes we're sending. But the other side, we're only receiving 32,000. And that's a problem in Python. Python has a send all function that can send, like guarantee to send everything, but the problem is not from the sender, it's from the receiver. It's too bad that Python, like the almighty Python, doesn't have a receive all function. Too bad. So we can't receive everything. We have to do something about it ourselves. We have to write our own receive all function to make sure we're receiving all the data. So how do we do that? We have to keep receiving until we reach the end of the data. But how do we know we reached the end of the data? You have like there are like 3 or 4 ways to do it. First one is to this is the easiest one. This is the one that I'm using. It's working fine. You can first send the length of the data and then send the actual data. Now you can just use a while loop to keep receiving data until you hit that length. So we have a simple code here, show you how to do that. The second fix is to use a delimiter in your code. So we are using base64 to encode our data. Since base64 is not using any special characters, so we can use those characters at the end of our data to mark it, like this is the end of our data. And at the other side, once we decode our data, we can still keep receiving until we hit that delimiter, and then we know that we received all the data. Okay, now we get to the interesting part. So how do we inject meterpreter into a running process remotely at the other side? So here we can use the C types. From C types and import everything, and then you can use the shell code as a variable. But well, this works fine if you're doing this on a local on the same computer, like locally. But if you want to send your shell code remotely, well, this one didn't work fine with me. So what I did is I created a meterpreter shellcode, a binary shellcode like .bin, and then I sent that file to the backdoor. I'm not writing anything on disk at the other side, so I'll receive the binary file, not using like write binary. I'll just use that to inject it into a running process. Well, this is the only way that worked with me, and it's working fine. Now we get to the download and upload. It's very easy. Anyone like using like C programming or Python, you know how to do like the read binary and write binary, or vice versa. So our backdoor in this case is the client. It's the one reading because you want to download a file. It will read the file as binary, send it to the socket. The other side will, the server side will receive the binary through the socket, and then it will write that binary to a file. You just give it a name. The last part is to how to create a exe file with Pyinstaller. So here Pyinstaller gives us a lot of options how to do that. The first option is the one file, or -F. You can create a single executable file, and also you can use the no console. I mean, you have to use the no console if you're creating a backdoor. You don't want it to appear to everyone and like, hey, this is my backdoor. Can you close it? You don't have to use the UPX option. But yeah, I mean, one file, no console, that's the most, like the two arguments that you want to use. You can also create that using Veil, using the Pyinstaller wrapper. Well, it's a good one. Actually, Veil has another module that it will actually encrypt change the signature every time. It will using the it's actually using Pyinstaller, but every time you create it, it will have a different signature to it. So that's a good one too. Okay, so we get to the demo here. Okay. So I call it the plagas, less plagas backdoor. Here we're generating our plagas using the Pyinstaller. Everything is happening in the background. You're not seeing anything. The exe file was generated. We're closing this one, the Kali. I only use Kali in this example because too bad macOS just updated our operating systems, and they just canceled no 32 bit applications is not running anymore, so everything is 64. So I can't run Wine on my Mac anymore. Thanks, Apple. Yeah. So here we're sending the file to our two virtual machines, one by one. And then we're switching to a public IP address, just to make it real. Okay, this should get a public IP address. Thanks, Kelly. We don't need you anymore. So this specific backdoor, it's not actually, I'm not configuring any IP and port, because we are receiving the IP and port through email. So the backdoor will be running in the background. Keep checking on your email for a specific email with a specific subject. Once it finds that email, it will go and grab the content of the email, get the IP and port, and connect back to it. This is our command and control. It's listening on port 8888. And then I wrote another tool to send email to myself. Get the IP address first because I need to copy and paste that later. Using the sender, same email, doesn't matter. Receiver. The subject, the secret subject is get shell. So it will just keep searching and then until it finds that one. Well, success. We got the two sessions open once the email was sent. 2 different IP addresses, 2 different ports, sessions. This is like a meterpreter type thing. You can control your sessions, session 1 and 2. So now we can interact with our first session, our first victim. ipconfig, you're using commands like the DOS commands. Who am I? Yep. And then you can also background it if you want. Go back to our session 2, ipconfig. Just make sure the IP address is correct. Now we will inject meterpreter. Just make sure when you're creating a backdoor, you want to automate everything. You don't want to like spend a lot of time like creating variables and port and numbers and like spend 5 minutes like to do those kind of stuff. So try to automate everything. Maybe just one thing just you need to type. So here we need to find a process to inject our meterpreter to. Just forget about that MSF console thing. It just keeps flashing out of nowhere. Inject it to explorer.exe, injected successfully. We got our meterpreter stage. That's cool. We will just leave that aside. We go to our second victim. Same thing. It should open another MSF console, but I'll just close it. Just we can get all sessions in one window. No, yeah. I don't know why Siri opened on this one. We're just playing around, I guess. Yeah, we're using a different, just make sure you're using a different port. Yep, we got the second meterpreter. We can now, you can close the plugins now. You don't need it anymore. You got meterpreter. I mean, also, it has a function that you can inject, like infect the target on boot time. So if it's log off or reboot, you can get meterpreter session. We will do that in a second. Yeah, I forgot about LS. It was diarrhea. Okay, so I think now we're about to download some files, I guess. Yeah. We will, using the download function that you just saw on the slides. I'm just trying to grab a random file, I don't know, like I'm choosing this one. Yeah, I just wanted to make sure the video is short. I didn't want to show you like the actual file, but yeah, I mean, if you're getting it done, that means it was successful. So yeah. So now I'm infecting the target since it's a plagas, like a parasite, so I'm infecting it with a meterpreter. So what I'm doing here is uploading a meterpreter script as a VBS script, uploading it the other side, write the VBS, and then write a memory registry key to execute that script on boot. Same thing here. It will like automatically open the MSF console for you, just in case. And then keep flashing like always. Yeah. Now you can log off, but here I don't know which virtual machine has this infection, so I need to check first IP address. Yeah, it's not this one. It's the one above. Yeah, it should be this one. Just making sure the IP address is correct. Yeah, so now here I'm just logging off and log back on. Just making sure I'm getting a session. Come on, Microsoft, like seriously. Yep, we got another session. This is using the infect command. You can also disinfect it, like remove the file, remove it from registry using the disinfect. Do that in a second. So as you see here, you're doing anything you want because you're using process execution. You can do almost all the DOS commands to do that. Yep, and I think we are done. There was another command I didn't type here. You can also control your session. You can kill one session from the command and control. You can just kill it, and you're not going to receive anything. So here we're infecting the other one, but that's gonna be it, I guess. Yeah, I'm just showing that disinfect command. We're not receiving any connection from it. Just close this one and disinfect it. Yep, that was it.
That's crazy.
So I have a question here. How would a target possibly defend against it? Well, okay, so first you need to have like updated antivirus, and also if you're not getting this one, so sometimes your UAC that you saw there, still I'm working on bypassing that. But if you're opening a file like exe file, it says unknown, or you're getting the UAC like kind of warning thing, do not open it. Just make sure this is something like weird. So also try to scan it, possibly upload it online if you suspect it. Try to scan it on multiple antiviruses online. Possible, like probably you will get like 10 out of like 60 at least. So if you see that, just don't open it. Just yeah, that's what I would do. Well, okay, thank you.
Has some more, like a quick demo of another like control features.
That was super cool.
Okay, probably not gonna work. I don't have my dongle. Dongle issues.
Do you have Thunderbolt? Can you borrow your dongle?
Oh, you want
Oh, is that cool? So I just wanted to show something that I finally finished since he went over like a whole C2 thing. So Dr. Whaleu last year did his dissertation on X509 C2 channel stuff. And I don't really want to get into it. Some of you probably know way more than me. But it's basically like the SSL certificate. You know, you go to websites, stuff like that. You can't really see. Oh, that doesn't work. Okay. So that's what they look like right here. And eventually, because of phishing, they added a bunch of extensions for security issues. But Cody referenced some researcher that found out you can embed data in the extensions. I don't know if you can see it. The subject alternative name and subject key identifier. Those are fields that you can embed data in. They're not really used for anything. So what we can do is I can enter a command, and this is going to go flush the SSL cert on one of my servers. So that's done. Oh shit. And then we can run the server and then the slave. So it's going to go and scan that. It's basically going to go to like google.com, and it's just going to like look at the certificate, but since there's like commands embedded and it knows where to look, it's going to run that command on the host. So I entered open calculator and it went to that website and it ran the command. So now we have a command and control over X509, so you can do whatever stuff. You can tell it to sleep and then quit. So the interesting thing is this is the initial, like, hey, I'm going to your website. And if you're like an enterprise defense person, you're not going to notice, random TLS traffic because people see millions and millions of packets a day. So there are two methods to do this. You can make the entire exchange just do these certificate exchanges, or what I did is just use both. You can do the initial connection over X509 and you can see like the certificate stuff here. And then the rest of the session is going to be TLS, like encrypted, so you're not going to know what's going on. So if you look, and because I didn't encrypt this one, you can see the original. Oh shit. I know I'm kind of just flying by, but I don't want to take up your time. If you scroll through, so Wireshark decodes it actually, which is really cool. And, whoops. So you can see right here, it decodes it as open calculator, but the actual certificate is just like garbled data. So there's not really any tools or defensive techniques you can do to search for this. So that's kind of interesting. So yeah, and then the commands are all garbage. So I don't know, that's cool. Yeah, that's it.
I think that's all we've got for this week, so hopefully people show up to the mock and should have a good time.
Go write your own tools.
Woo!